Hello everyone and welcome to a brand new game. I watched a little bit of gameplay of this game on YouTube last night and I really enjoyed it, so I thought I would get it myself and start playing it. I have literally not even pressed new game on this yet, so let's get started and see how we get on. Okay, that's me. Glad to see you in our game. This is a tycoon game that will give you the opportunity to take the role of machine learning specialist. Of course, you mean role of a machine learning specialist and develop from a rookie to professional. Yay! We hope that our game will help you to understand machine learning better. It is in the development stage at the moment, but we wanted to show the game to you already. Okay, let's give it a shot. Save. Back. Good morning. We are running a big social survey in schools and we've... Okay. What is that button? Oh, that's just see it more. And we've encountered a problem. Pupils often forget to mark in which grade they are in questionnaires. Can you divide pupils from junior and high school using their test sheets? So 100% accuracy, 35 seconds, reward $300. Okay, let's accept. Non-neural artificial intelligence. Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. Expert system is a deterministic algorithm which reproduces decisions of a real person in some cases. One of the examples of this is ELIZA, the first chatbot in the world. It was created in 1966 and talked with the patient using questions similar to real psychotherapists. It worked horribly. I don't know about you guys, but I remember talking to ELIZA way back when I was in high school. The computers in our school had this program that we could run, and it was kind of stupid, but it was surprising that it was not another human being at some points. But once you got past that first few sentences, it got a little repetitive. Okay, so what are we doing now? So we've got an expert system. So this must be the output, which goes into our input there. And then we've got the output. We've got two outputs, red. If it's red, it goes up to the top. So we want the reds there. And we have 10 reds and 10 blues coming in from there. And we want the blues to go there. So we'll do a test run. That's our time running down. That's our cost of actually running this algorithm. Just got to wait for it to complete. So one more. I think they all went down the right way. Success, estimated cost $42, time spent 21 seconds. Occupancy 9 out of 8. I don't know what occupancy is. Accuracy 100%. Okay. So release. Accept. Let it just go through and complete. Oh, I can increase the speed. That's cool. So I'll put it at 3, which is the maximum speed. Success. Perfect. Next project. So that's our cloud cost of $42, but we got 300, so our profit is 258. Great. Hello. We have some errors in our questionnaires data. We can't solve the problem. Can you fix it? I'll accept it. Let's see. What do they want? So they've got red, green, and blue, and they want just red and green. So that's fine. So they don't want blue. So we will send blue into the trash can because everything else will be the red and green, and we'll send them there, right? So red, green, and blue coming in from there goes through there. The expert system picks out the blues and gets rid of them, and everything else will go right there. So let's do a test run. Yep, looks right. Great. Occupancy 15 of 15, accuracy 100%. Okay, release. Accept. What's this, I wonder? Oh, that must be how full it is. I see. Okay, next project. Errors in database. To hello, it's us again. We've found some new types of errors made by our users. Please update your program. It will be easier if you will use the previous version of the code. Okay, so now it only wants red, and it wants us to use the previous version of our code. You can use programs which you've constructed while completing previous tasks. Here you can see all the schemes made of basic nodes which are allowed to be used in this task. Custom nodes don't waste time on transferring data from one node to another. Don't know what all of that means, but okay. At any time you can get back to the previous tasks and rewrite the programs. For example, you may optimize them for using in the current program. Okay, interesting. So we've got without blue, which is our previous program, and this time around we also don't want green, so we will take that and we will take the expert system, and I will do it this other way just because. So we got rid of blue there, we'll get rid of green here instead of picking up red. It makes sense to me in a weird sort of way. And green is the only one we want. Oh, green we want to throw out. Okay, test run. Excellent, and we'll release. Excellent. Next project. Optimization of the code. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? It must work faster. I enjoy making things work faster. Okay, so they want only red. Okay, so I guess we need to use this because that's faster than that. And we want just red. So let's make this any, and we want red there. What happens if we do that and we take the trash can, we put everything other than red into the trash? Let's test run that. So red went there. Oh wait, why is some of the red going? Okay, test run failed. Okay, so we don't want, so this is a decision tree, so only red will go through there, but red or any of the other colors will go through there. So what if we make that green? So green and blue goes there. And did we see red and blue? Did we see, was it, yep, red and blue goes through there and green and blue goes through there. So what that means now is that red will only go through there, green will only go through there, and the blue will go through either of those. So what we need to do now is we need to filter that again. So red will go there, and we will take blue and send that there. Let's test run that. Yep, only red going there. Perfect. And let's release it. Perfect. Next project. Illuminati origins. Good day. I study ancient manuscripts and books in order to find the very beginning and truth about Illuminati secret society. We need to find all triangle figures in these documents to solve the puzzle. Can we do it using a program? Of course we can. We will use the sift. Wait, can I get information about this? I guess not. So we want triangles. Else, send it to the trash. What if I don't send it to trash? Oh, that one fills up. And then it fails. Okay, it just gets stuck. Okay. That's why we need to do that. Test run. Okay, so it holds it there while it sends it through the other places. Okay, that's interesting. So this must be like a buffer there, buffer there, buffer there. Fine. Makes sense. Got it. Release. Accept. Got a bunch of money. $1,600. Not bad. Next project. Accept. Good morning, Tovarish. We know that someone from the USA created a system which can recognize the alphabet. You must create a copy of that system for KGB. The handwriting of USA spies is awful. Accept job. First perceptron machine neuron was invented by Frank Rosenblatt in 1957. Frank created Mark 1 in 1960. Mark 1 is a perceptron machine that can recognize English letters by their shapes. Very interesting. Okay, so now we're going to use a perceptron, and the error rate is 75%. Circle, I think we need error rate. What error rate did we need? I forget. Triangle, let's test run. Oh, there's a question mark here, so maybe that'll provide me with help. Maybe after this test run. Oh, success of 56%. The error rate has gone down. Okay, so I can just click that question mark. In test run, perceptron reduces the amount of errors while trying to predict the shape of elements. In deploy run, perceptron only predicts shapes. Oh, I see. So when you test run it, it reduces the amount of errors. So if I test run it again, oh, 20% is as good as it's going to get. Oh, it's going up. Okay, fine. Stop. Release. Making plenty of money. If only it was this easy in real life. Text recognition. We are aware that you were able to create a text recognition system based on the Rosenblatt perceptron. We need a similar system. You must teach it to distinguish vowels from consonants. The task is simpler, but more accuracy is required. So we need 50%, 52 seconds. Okay. So we need wait a minute. So if we take the circle and the square, we don't have a trash can. So how do we get rid of test run? Oh, wait, stop. So this one wants the circle and the triangles, and that one wants the square and triangles. Okay, so how would... Okay, that is a good question. Test run. So that's the accuracy. So we've got 75% accuracy going there. Would that work? It was success. This one is filling up a bit, but oh, maybe, oh yeah, okay. That one filled up. It's a success. I'll take it. Good afternoon. We've already bought Christmas trees for the holiday. Friends said that you can calculate when the peak demand for the goods will be. Help us, please. Okay. Darkest Years of Machine Learning. In 1969, Seymour Papert and Marvin Lee Minsky wrote a book called Perceptrons. In this book, they talk about math constraints of the first perceptrons. Zohr problem. This book has shifted the scientific interest in subsidies of the US government organizations and slowed machine learning for almost 30 years. The expanded version of the book was released in 1987, containing the chapters that disproved the statements from the critical remarks made since 1969. Wow. Okay, so we have red, green, and blue. We want red, green, and blue there, and only green there. Wouldn't that make... Okay, so red, green, so that'll give us red and blue, and this will give us green and blue. And here we will have green and blue. So that goes green and blue, there, there. Test run. So that'll split the red, green, and blue into red and blue, which is valid there, and green and blue, which gets split again to just green, which will go into this bit, which is just green, and the blues go up there. So we'll release that. Perfect. Except parallel calculations. Hello, we write to you from the Science Center. Our current programs run very slowly. Can you parallelize our calculations? Except job. I'm just curious, is that all we can do? We don't have any startups yet. Okay. Yes, let's parallelize your thing. Okay, so is this all it takes? So it just splits it into two different bits. Oh, easy. Release. Next project. Hey, our parallelization system broke after the last doors OS Windows doors. I get it. Haha. Upgrade. Can you fix it? It's a very big system. Be careful. Doesn't seem very big. Oh wait, okay, I get it. So you need 2. So it just needs to be split into 4. That's all it is. So that goes there. That goes there. We need 1 more of those. That goes there. That goes there. And that goes there. Just run. Look at that. Magic. Release. It's actually pretty colors. Dictatorship. Greetings. This is the only state provider of a small country. We have a very suboptimal code to track our people activities. Unfortunately, we cannot allow you to change the code, but we have several new servers purchased on sale. Parallel the calculations. This will help our tyranny to prosper. Wait, do I not have a choice? Oh wait, startups. Oh, private. Okay, I have mail. Okay, read. Good day, we are inviting you to join our hacker startup. We write cheats and guides for different games, but we would like to create something very cool now. We need a program that will play and win in Arkanoid instead of the player. We know that you know a lot about machine learning, so we are inviting you to participate in our startup. Oh. I'm not sure if that's cheating, but you know what? Let's do it. The scheme created while working at a startup does not differ from a usual task one, but it can work better or worse. Your profit depends on the quality of the scheme. Continue. In startups, when you press release, your scheme starts to work automatically. Don't worry, you can get back to the scheme and change it anytime later. If your scheme contains self-learning nodes, you can disable learning in test run. Okay. Wait. Okay, so I've started this, so I need to run it before I can... Wait, what am I supposed to do here? Okay, so red, green, and blue. So we want efficiency. So this is... Okay, blue. Wait, so that'll be red and green and blue and green. No. If I make that green, then all the greens will go there. That'll be red and blue. I will still need to tidy it up, I think. But that's fine. I mean, these things happen in parallel. So red and, okay, I should have this blue. Yep. So red and green, blue and green. So red goes there, blue goes there, and green goes there, and green goes there. Test run. Oops, I forgot to connect it up. Test run. Yeah, that seems straightforward enough. I mean, we are not getting a... Maybe that's pretty full buffer-wise, but it's not too bad. Yeah. And the other option is to use an expert system. So that is 0.3 plus 0.3, which is 0.6, which is still faster than the 1 second. Yeah, okay. Release. Accept. Launching a successful startup or successful completion of a task requires 1 day. In the end of the week, every startup provides you income. The money histogram shows the dynamics of weekly income. The numbers indicate the income received during the current week. The red column states that users brought you less money than you spent on servers that day. Makes sense? The user's histogram shows the dynamics of the number of users taking part in the startup. The number indicates the number of active users at the moment. If the number of users exceeds the bandwidth of your scheme, overload grows. The overload histogram, overload histogram shows the overload dynamics. The number indicates the current overload. If the overload gets massive, try to optimize the scheme. Okay. Okay, so current users 100, current overload 0%. Fine. That's fine. I can deal with that. So let's go here and let's check our private email, mail from parents. Hello dear, we remember what you've said, but your birthday is coming soon, so take this money and buy yourself something tasty. We love you very much and we missed you. P.S. Do not forget to put a hat on. It's very cold outside. That's a lot of money for free. I'll take it. And job. Oh, we've got quite a few. Oh no, these are the ones that we've already done. Okay. Dictatorship. Okay, we saw that. Read, sorry, accept. So it needs just red. Okay, so this is the parallelization. I am guessing that, considering the fact that we have this, it's not going to be fast enough. So let's try 2. So we are still only interested in red. So we'll take the red there, trash can. So all we're really doing is we're filtering the red out. But by parallelizing it, it will take half the time than if we were sending them one at a time. So let's test run. Yep, that's getting stuck. You failed. We ran out of time. Which reminds me, we have a filter red one in here somewhere, don't we? Or else divide without blue, only red. So let's get rid of these. So only red is a bit cleaner. So let me take another only red out and see. And I don't imagine that'll be faster, but it's tidier. Wait, I think that one uses. Can I see what that only red does? So as only parallel block. Wait, where is the only red? I want to know. Wait, custom nodes. Only red. I can't see what that one does. Only parallel blocks, no text. Let's look for one where it's only red on that side, this one. So without blue, expert system, that shouldn't be that fast. I'm not sure how that only red. Yeah, because that's 1 second. But somehow that is faster. I'll take it. Okay. Maybe because it used 2 servers. I'm not sure. Next project. Prediction of president elections. The president of our partner company has been dismissed last month, so there is an election running right now. We need to know who will win the election to decide what to do with the relationship between our companies. Do it and you will receive a payment. Okay. Accept job. Wait, what? Okay, so what we need here is we will use only red for parallel, only red fast, and we will base nodes, we will split that out across these two. We ran out of time. In which case, let's do it the other way around. Let's put that there, and let's take another one of those, only red fast, and do it this way. Test run. There we go. Release. Shabam! We'll do one more and then we'll call that the episode. Hello, this message is from Oscar Committee. We want to replace some of our experts with the help of a neural network. Write a system that can rate the films by their type. Okay. So we want red and green there and red and blue there. This seems like a job for a decision. No. Wait, so okay. For a decision tree. So we want that is interesting. So red and green there and red and blue there. So they both want red. So okay, so that's easy. So we do green, sorry, we'll do blue there and red there. So that'll be, sorry, no, green and blue. So red and green will go there, and red and blue will go there. That seems easy, but I suspect we will need 2 of those because we probably don't have enough time. Blue, let's speed it up. Because the way this will work, of course, is that you will get green and whatever other color, and blue and whatever other color, which is red. So red and green can go there, and blue and green can go there. Red and green, blue and green. Let's test run. Complete and success. Good. Release. Okay, next project. I'll accept the cash. Oh, that's perfect. This check shows the startup's weekly profit statistics. Only $86. Oh no, wait. Revenue, okay. 505, 419. That's fine. I was aware of that. Continue. Summary. Launching a successful startup or successful completion of a task requires 1 day at the end of the week. Yeah, we already read that. Or you can leave the startup. You won't receive or lose money, but the startup will be deleted. Okay, accept. Okay, how do I go? Okay, we've got another startup, self-driving car. Okay, how do we go back? Okay, weekly income, current users 112. There is no overload there at all. That's fine. That's great. Well, we'll call the episode there. Thank you very much for watching, and we'll see you next time.